Hi, this is Chris with Sanderson Test Prep, and we are finishing our last couple grid-ins in Section 3 of SAT Practice Test 1. So here we're looking at numbers 19 and 20. And for 19, it says in a right triangle, one angle measures x degrees where the sine of x equals 4/5. What is the cosine of 90 minus x? So we could see the sine and the cosine and start thinking to ourselves that this is going to be a question involving SOHCAHTOA. And it is, but we're going to see if we can learn a little shortcut around that later on. But first instinct that a lot of people have when they see a question like this is to draw out a triangle, and that's a great instinct. It's definitely something that we should do. So let's draw out a triangle. So it's a right triangle. And let's see what we can label. So if we call this x, the sine of x using SOHCAHTOA is opposite over hypotenuse. So that means that this would be our opposite, and this would be our hypotenuse down here. So this could be 4, and this could be 5. Now we have to figure out the cosine of 90 minus x. And this is something where it's often forgotten. This can actually be treated as an identity. And if you recognize the identity, you don't even have to draw out the triangle. But with our triangle in front of us, I'll show you where the identity comes from. All of the angles of a triangle have to add up to what? So hopefully when you hear that, you're thinking to yourself, oh, they have to add up to 180, which is correct. And if it's a right triangle, well then we already know that our right angle is 90 degrees. So if you subtract that from 180, you're left with 90 for these remaining two angles. So x and then this other one have to add up to 90 together, which means that regardless of the value of x, this missing angle over here will be 90 minus x. And that relationship is key, because in a question like this, when they say the sine of x is 4/5 and they want to know the cosine of 90 minus x, it's really, and I think this is a great way to think of it, instead of thinking 90 minus x, just think of it as it's the cosine of the other one. It's the other angle. So they're giving you the sine of this angle down here of x, and then they're asking you for the cosine of this other angle. And if we think back to our SOHCAHTOA, cosine is adjacent. So if we're looking from this angle up here, the adjacent side is going to be the 4 over the hypotenuse, which will be a 5. And our correct answer to this question will be 4/5. And it is no coincidence that that happens to be equal to the sine of x. So that's an identity that's worth memorizing. And I oftentimes say that to get that answer, we can avoid all of this, if we want, just by memorizing that sine x equals cosine of 90 minus x, and it works in the opposite direction as well. That cosine of x will equal the sine of 90 minus x. And there's two other ways that you might see this. Sometimes they'll use two different variables. So actually, let me put the sine first. Sometimes you'll see it as sine x equals cosine y, where they label the other angle with a different letter, and then sometimes you'll see cosine x equals sine of y. So I highly recommend memorizing all 4 of these statements as a triangle identity, and then using that to your advantage on a triangle question to be able to eliminate having to draw things out and use SOHCAHTOA to figure it out in more complex fashion. And this is oftentimes a place where I use the phrase content corrects pacing. A lot of times in math, if you memorize an extra piece of content, make that extra flashcard or create a Quizlet for yourself, whatever's easiest. But if you memorize that extra piece of content, a lot of times it can save you a lot of time and maybe help any pacing issues that you might have on the test. Now let's take a look at 20. And as we saw, our difficulty level reset when we got to the grid-in. So 16 was easy. By the time we get to 20, this is supposed to be a pretty tough question. And it is for this. So when you look at it, they give us a equals 5 root 2, If they just said a equals 4 or some other number, we would feel more comfortable plugging it in for a, but plugging this in terms of our approach is going to be the same approach, but the numbers are going to look a little funky because we have these roots in there. But let's still try plugging it in, and let's see what happens. So this will be 2 times 5 root 2 is equal to the square root of 2x. And the way we distribute the 2 into that parentheses, we multiply the 2 times the 5. The root stays as is. That would be 10 root 2. And then here, in order to eliminate the square root, we can square both sides. So if we square both sides of this equation, on the right side, that will just cancel out the root. Whenever you have a square root, if you square it, it cancels out the root. And that would be the same with any kind of root. So if you had a cube root, you could take both sides and cube them, or take them to the third power to cancel out that root. And even if you had something a little funky like the 11th root, if you took it to the 11th power, it would cancel out that root. So for square roots, to cancel them, you square both sides. So we'll be left with a 2x over there. And then this is the part that a lot of test takers run into trouble with, because it's a little bit more difficult to know how to square this complex looking expression of 10 root 2. But you're just going to square each piece individually. So 10 squared is 100. And then as we just mentioned, root 2 squared, when you square a square root, it cancels out the root. So this would just be 100 times 2 equals 2x. And when you have 200 equals 2x and you divide by 2, you'll be left with x equals 100. So there is some challenging math on this one, and as there should be, because as we said before, question 20 of our grid-ins, in theory that's going to be the hardest one, and this one does indeed test a little bit of our more complex math skills in terms of being able to multiply and take roots to exponents and try to isolate a variable and even plug in, a more complex expression than we sometimes see rather than an individual number. So there's a lot of skills here that maybe make this a little bit more challenging, especially at first glance. But that's how we tackle question 20, and that's the end of section 3. And stay tuned and take a look at our next section, section 4, which is the calculator math.